Stellar generations. When we talk about stars, we talk about the fact that when a star dies, its material is blasted back into the interstellar medium. To make new stars. So stellar generations deals with this idea that the death of one star leads to the birth of new stars made from its remnants. And each new generation is made from the remnants of more and more of the previous generations of stars. So stars affect the chemical elements available. We know that. We know that you have fusion producing heavier elements. So when our universe began, the only elements available were hydrogen and helium. And our little pie chart here shows roughly the percentages. Hydrogen was about 75% of the early universe, and helium about 25%, very roughly. So the first stars were formed out of just hydrogen and helium. But of course, when a star goes through its life cycle, it uses up the hydrogen and helium and gets to the point of producing carbon and oxygen in red giants. So now we have a small percentage of elements that aren't hydrogen and helium. And then, of course, in the larger stars, we go beyond the carbon and oxygen to also getting neon, magnesium, silicon, iron. But these are going to be in even smaller amounts because only the highest mass stars produce this. So, carbon and oxygen, hydrogen and helium, those are going to be more common. The things beyond carbon and oxygen are going to be even more rare. And then, of course, the rarest of elements, everything else, is going to be produced in a supernova. So these are going to be incredibly rare. So when we look at stars, we can look at their compositions to get an idea of how many generations came before them, because that's going to dictate the amount of heavy elements that make up the star. So first generation stars, these were the first to form. And of course, the lowest mass first generation stars are still around. So these are also going to be the oldest stars we see. And these are going to only be composed of hydrogen and helium, that original mix from when our universe began. It's only when you get to later generations, ones that have formed more recently, so these are the younger stars, that are going to have this addition of heavier elements, up to about 4% heavy element composition. That's about what we see in our sun and what we see in other stars that have formed in more recent eras. And so this pie chart shows us roughly 4% heavy elements, and we'll call this, instead of 75%, 72% hydrogen, and what do we got? Say 24% helium, something like that. Again, very rough estimates of numbers, but something along those lines is what we see in the stars that are formed present day, and stars like our sun. So these generations tell us not only what the composition is, but also when was it formed.